Okay, do you know map and flat map in Stream API?
Yeah, in Java 8 Stream API, map and flat map are two key methods used for transforming and manipulating data in streams. So, map in case of map, we pass stream and we further it returns a new stream with the transformed element. But in case of flat map, we pass a stream of a stream and it further flattens it and passes that stream of a stream into the single stream. So this is the major difference between these two.
Okay, suppose I have a employee class and it has two properties, let's say name and age. Now I want to get the list of names only. Suppose I have a employee class and it has name and age, these two properties, and out of it I want to fetch only list of names. Okay, so how can I achieve it? Should I use map or should I use flat map?
Yeah, so to achieve this, we should use map method, not flat map, since we want to transform each employee object into its name only, I mean a single value. We don't want another property. So the best way is to use the map.
How multi-threading handled in Java?
Yeah, multi-threading in Java is managed through the use of the java.lang.thread class and the java.util.concurrent package. The thread can be created using two ways. So first way is it can be done using extending the thread class. So we can create a new class that extends the thread class and then we override its run method. The second way is using implementing the runnable interface. We can create a class that implements the runnable interface and pass an instance of this class to a thread object. So this is the another way.
Okay, so what are the various states of the threads?
Yeah, a thread in Java can be in the various states. So we have new, runnable, blocked, waiting, terminated. So yeah, so these are the various states. So
Okay, what is executor in Java?
an executor in Java is a high-level tool designed to simplify the management and execution of tasks in a multi-threaded environment. Instead of manually creating and managing individual threads, an executor provides a way to manage a pool of threads, handle task execution, and control the life cycle of threads. So we have various types of executors. We have single thread executor, we have fixed thread pool, we have cached thread pool, we have scheduled thread pool. So single thread pool uses a single thread to execute task sequentially. Fixed thread pool has a fixed number of threads to handle tasks. Cache thread pool creates new threads as needed, but reuses existing threads whenever it is possible. And then we have the last one is I think scheduled thread pool. So it can schedule task to run after a delay or periodically. These are the different types of executors we have.
Okay, so can we use get method to update or create the resource?
We can use the get method to update the data on the server, but it goes against the recommended uses and the principle of HTTP method. So because of the safety reasons, so get requests are considered safe operation that do not modify or have side effects on the server. So server and intermediaries like proxies may cache get response, assuming they do not change the server state. Using get for updates could lead to unpredictable caching behavior and unintended consequences. So get requests pass parameters through the URL. So updating data via get could expose sensitive information, potentially compromising the security basically here. And second thing is that uh, we have some, I think, some length restriction is there. So I think up to 1024 characters only we can pass uh, into the URL through the GET request. So more than that, if any data is there, so we cannot pass that. So that is also one problem we will face. So normally RESTful API design encourages using HTTP methods according to their intended purpose. So we have post, put, patch, delete. So all those methods should be used as per their requirements. So yeah, it can be used, but yeah, these are the problems we have.
Okay, so what are the HTTP headers used for?
Yeah, HTTP headers play a crucial role in HTTP communication by providing additional information about the request or response. So, suppose if we have to do authentication and authorization, and we have to pass like content type, content length, so content like JSON and all, right? So I mean, then we use header. So header is the place where we use all this. So caching and validation also we uh, use for that, and then for security. Uh, so all these things we use under header only.
Okay, what will happen if you have only try block and finally block, but there is no catch block? So can you tell me with the scenarios and how it will behave?
Yeah. So we can have multiple scenarios. So suppose if there is no exception happens. So suppose we have a try block and let's say some division we are doing like 10 divided by 2, something like that, and there is no exception at all. So I mean, no exception will be thrown, and directly after try block, the finally block will be executed. So finally block basically always executes irrespective of catch is there or not. And yeah, so the another scenario can be like uh, the exception is thrown but not caught. So suppose we have something like 10 divided by 0. So in this case, ideally it should there should have been the exception. So an exception occurs inside the try block. So in this case, what will happen is so the arithmetic exception will be propagated up the call stack after the finally block executes. So it will throw the arithmetic exception. So there can be another scenario when we have the exception is thrown and caught higher up the call stack. So in this scenario, the exception is thrown in try block and is not caught, suppose within the same method, but is caught in the higher up the call stack. So from where the method is being called, so the exception will propagate to there, and it will be further exception will be thrown. So in this case also, like try will run first and then finally, and then it will go to the parent catch block and it will be executed. Then we can have another scenario when exception thrown and the method returns. Suppose the return is there. So in this scenario, an exception occurs in try block and the method that contains the try finally structure is expected to return a value, suppose. So in this case also, like, the arithmetic exception is propagated up the call stack after the finally block executes. So in all these scenarios, the finally block executes regardless of whether an execution is thrown in the try block or not. The purpose of the finally block is to ensure that cleanup code runs uh, uh, no matter what happens in the try block. So any cleanup code is there or any connection clause is there, so those things we run in the finally block. So this is useful for tasks such as closing files, releasing resources, or other cleanup activities. So if an exception is thrown and not caught within the method, it will propagate up the call stack after the finally block executes. Yeah.
Okay, so what is the super class of all the errors and exceptions in Java?
Yeah, throwable is the class that is the super class.
So how do you resolve this out of memory error?
Normally, one way we use is like we increase the size of heap, but that we can do. But apart from that, we should also consider doing few things like we should analyze and fix the memory leaks if any is there, and we can optimize. Suppose some data structure has been used in the code and it is not optimized, so in that scenario also we can see this issue, so it should be optimized. So we should use collections wisely in this case. So we should prefer array list over linked list for smaller data sets. So we and use hash maps and hash set with an appropriate initial capacity to avoid resizing overhead. And we should avoid large objects, and large objects should break into smaller objects. So these are the few things we should do. Code optimization also. Wherever the resources has been opened, we should uh, close try closing the resources. Suppose for example, if we are reading any text file using buffer reader or something, so we should try to release the that resource once we are done reading with it. Yeah, so these are the few ways we should try, and this out of memory can be resolved.
So when would you choose hash map over hash table?
Hash map allows null values and is not synchronized, making it more efficient in single thread scenarios. So it offers better performance for most applications. So whereas a hash table does not allow null values and is synchronized, ensuring thread safety in concurrent environments, but with a performance overhead. So the performance will be slower in case of hash table, whereas hash in case of hash map, so it it is not slow. I mean, that is faster than hash table.
Okay, so when we define a string, we define it as literal and as new object, right? So can you tell me what is the difference between these two?
Yeah, in Java there are two main ways to create a string, using string literal and using the new keyword. So these two approaches have significant differences in terms of memory management and performance. So in case of a string literal, we just say string str equal to, let's say, ABC in double quotes. So a string literal is a sequence of characters enclosed in double quotes. When you create a string using a literal, it is automatically added to the string pool. So the string pool is a special memory region in Java heap where string literals are stored. If a string with the same content already exists in the pool, the new reference point to the existing string instead of creating a new one. So it is so using string literals is memory efficient because it reuses existing string from the pool, if they have the same content. Now coming to the creating it using new. So using the new keyword explicitly creates a new string object in the heap, even if an identical string already exists in the string pool. So each new string object is stored in heap as a separate object. Okay, so we define it like using new string, and I mean in double quotes we can say whatever abc. So creating a string with new keyword can lead to higher memory usage since it does not leverage the string pool for use. Yeah.
Okay, in Spring Boot, what is component, repository, and service?
Yeah, in Spring Boot, this add component, repository, and service are uh, three of the primary stereotypes that define different types of Spring managed components. These annotations help Spring identify and configure the components for dependency injection. So, for example, when we use add component, so it is a generic stereotype for any Spring managed component. So it is a generic annotation that can be used to mark any class as a Spring Bean. So whenever we use at the rate of component scan or enable component scanning, Spring will automatically detect classes annotated with add component and register them into the application context. And then at repository, so we use it at the persistent layer. So at repository is a specialization of component used to indicate that the class provides the mechanism for storage, retrieval, search, update, and delete operation on objects. So for exception translation also it is used. So it also provides an additional feature which translates database related exceptions into Spring's data access exception. So basically we use it as a data access object at DOA classes, so which interacts with the databases. Then coming to service layer, so there we use add the rate of service. That is a specialization of add component only, so which is used to indicate that the class holds the business logic. So it tells us that okay, this is the class where all the business logics are there. Yeah.
Okay, so can't we use add component itself everywhere? I mean, at the place of repository and service.
Yes, technically we can use add component for all our Spring Beans, including repositories and services. Since at the rate of repository and at the rate of service are just specializations of component only, add component only. So they provide the same basic functionality of marking a class as a Spring managed bean and enabling component scanning. However, using the specific annotation has some advantages. So actually we should use at the rate of repository and service only. So for example, like in case of at the rate of repository, so so that provides the functionality related to persistence such as exception translation. So when Spring detects a at the rate of repository annotation, it automatically applies a persistent exception translation mechanism. So converting native persistence exception to Spring's data access exception hierarchy. So this is one additional advantage we have when we use at the rate of repository. So however, when we come to at the rate of service, so it does not have additional functionality like at the rate of repository, but it serves as a marker for the service layer. So basically, the I mean all these annotations work as a marker for the corresponding layers. So for example, at the repository, so we come to know that okay, so this is something related to the database and we're going to fetch from there. And at the top service we come to know that okay, this will have some business logic and all, right? So yeah, so this is the advantage we get So, but yeah, that is also true that if we don't use the specific notations, still it will work perfectly fine. Yeah.
Okay, like we have these components. Can you create your own custom components?
Yeah, we can create. So creating custom component in Spring involves defining your own notations that are then interpreted by Spring to manage beans. So this approach helps streamline configuration and maintain readability by encapsulating common configurations or behaviors into reusable annotations. So for that, like we first of all we define our custom annotation using Java at the rate of interface syntax. So we can annotate this custom annotation with add component to ensure that Spring recognizes it as a bean. So I mean wherever we are writing this interface public at the rate of interface, and then we can do give our custom service name, and on top of that at the rate of component should be there, so that this and add that component stereotype for Spring managed components. So now uh, wherever we want to use that our custom service, so on top of our class we can suppose we have some my custom service class is there. So on top of that we can mention this at the rate of custom service which we have created. And one more thing we need to do that, so we have to enable it. So we have to enable this component scanning, so that also we will have to do. So we have to ensure that our Spring application is configured to scan that package where our custom components are located. So we technically do this by using at the rate of component scan notation on our configuration class. So in so normally wherever we have at that of Spring Boot application, so there we can add it. So once configured, so Spring will detect and manage classes annotated with at the rate of custom service just like any other Spring managed component. So you can inject them into other beans and use them in dependency injection scenarios and benefit from other Spring features such as auto wiring. Yeah. So this is how we can do this.
Okay, can you explain what is load balancer does in the context of microservices?
Yeah, sure. So in microservices setup, a load balancer, we can think that it acts like a traffic cop for incoming request to our services. So imagine our services are like different lanes of traffic on a highway, and the load balancer is there to ensure no single lane gets too congested or overcrowded. So it just passes all the request to the wherever the some uh, bandwidth is there, we can say, and the congestion should not happen. So uh, one highway should not be blocked, you can say. So yeah, so that's what basically in the layman term it is.
Okay, how does it work exactly?
Well, when a user makes a request to our application, let's say to view their profile or make a purchase, that request does not go directly to just one of our service instances. Instead, that load balancer setup in the decides which a specific instance of our service should handle that request. So it is a load balancer which decides. Okay, so it looks at a thing like how busy each instance is, how healthy they are, and then directs the request to the best available option. So that is how actually it works.
So does it do anything else apart from this?
Yeah, it also helps us to scale our application seamlessly. If we anticipate more users or need to handle increased demand, we can simply add more service instances. The load balancer will automatically start distributing incoming requests across these new instances, making our application more elastic and able to grow as needed. So it's like having a smart traffic controller that ensures every part of our application keeps running smoothly and efficiently. It's key part of how we ensure our users get the best possible experience with our services.
Okay, what is service discovery?
Yeah, service discovery is the mechanism that allows microservices within a distributed system to find and communicate with each other dynamically. So, in a nutshell, it's like having a phone directory for services. Each service registers itself with a central registry upon startup, providing its location and metadata, such as its name and version. Other services can then query this registry to discover where and how to reach a particular service they need to interact with. This dynamic lookup ensures that services can adapt to change in the environment, such as scaling up or down, without manual intervention. So it's crucial for enabling flexibility, scalability, and resilience in microservices architecture, supporting features like load balancing and fault tolerance seamlessly.
What is JPA?
Yes, JPA stands for Java Persistence API. So it's a specification in Java for managing relational data in applications using object relational mapping. So there are various implementations of that. For example, Hibernate is there. So it is a popular and widely used implementation of JPA. So Hibernate provides additional features beyond JPA specification, and it is known for its performance and flexibility. So in summary, JPA is a powerful tool for Java developers to manage relational data persistently in applications, providing an abstraction layer over database interaction and facilitating efficient data access and manipulation.
Okay,
Yeah,
do you know
database
what is
replication is the
database
process of
replication?
creating and maintaining copies of the database or parts of a database across different servers or location. So this technique is used to improve availability, reliability, and performance of the databases, especially in the scenarios where high availability and fault tolerance are critical. So uh, so if suppose if you want maximum uptime, so we do that using this. So by maintaining redundant copies of data, replication ensures that if one server or database instance fails, another can take over seamlessly. So it just minimizes the downtime, and then it improves the performance. So replication allows read operation to be distributed across multiple servers, reducing the load on the primary databases server and improving overall query response time.
So, can you tell me the difference between where and having clause in SQL?
So the where and having clause in SQL both used to filter rows returned by a query, but they operate in different contexts and having distinct purposes. So where clause is used to filter rows before any groupings are made. So if suppose we have some query but there is no grouping, so we have group by, right? So if that is not being used, so then we go for where. So it appears immediately after the from clause and before any group by or order by clause. So it filters rows based on the conditions involving column of the tables in the from clause. So for example, select column 1, column 2 from any table where condition, right? So here like where that condition is applied to filter individual rows from table name before any grouping or aggregation. Now suppose we have the having clause, so that is used for filtering rows after the group by clause has grouped the rows. Okay, so it appears after the group by clause and before order by clause. So for example, we can say like select any sum of, suppose any column is there, so and from some table where group by we can say any column name and then having something if you want, so that also we can apply. So in summary, with both where and having are used for filtering data SQL queries, where filter rows before the grouping occurs and having filter groups of rows after grouping has been applied using group by.